In lesson 9-1, we're going to talk about the square root method and the completing the square method, which are two methods to factor in quadratic equations that we didn't already talk about. So there's three different methods of solving quadratic equations. The first one is the one we talked about in the last video, so that's factoring. And then the other two are square root method and completing the square method. And those are the ones we're going to talk about today, these two. All right, first I want to solve x squared minus 12x plus 5 is equal to 0 using the factoring method. So the factoring method, since I have a 1 in front of the x squared, I know I can go directly from the diamond to factored form. So I'm going to do the diamond when I see a quadratic expression like that on the left-hand side. I need two numbers that multiply to 5 and add up to negative 12. What two numbers multiply to 5 and add up to negative 12? The answer is, there is no answer. You can't factor this thing. If you can't do the diamond, that means you can't factor. It's not factorable. So I need a different method. I need a different method because that method doesn't work. The factoring method doesn't work. Okay. So one other method that I can use is the square root method. First step to the square root method is I'm going to isolate. So I'm going to isolate the square. So whatever I have to the second power, that's what I'm going to get by itself on one side. Then after I do that, so for example, if I had like x squared minus 5 is equal to 0. What I would do first is I would isolate the x squared. So I would add 5 to both sides. And that would give me x squared is equal to 5. So I would isolate the square, get the square by itself. Then I'm going to take the square root of both sides. So I'm going to take the square root of both sides. And when I do that, I need to keep in mind that, so make sure you don't forget this. This is one of those really annoying things in math that everybody always forgets. I forget all the time. If I take the square root of something, if I decide to take the square root of something and the square root isn't already given to me, I need to make sure I include both the positive and the negative answer. So I write plus or minus whatever answer I get. So in this case, let me make this actually a nicer number. So let's say I had, let's leave it like that. Okay, so I started with x squared is equal to 5. What I'm going to do is I'm going to take the square root of both sides now. And that gives me x is equal to plus or minus the square root of 5. So that's what I'm talking about, the plus or minus. You have to include in front. So it either could be positive square root of 5 or negative square root of 5. And I leave it as the square root of 5 because the square root of 5 is, 5 is irrational. Sorry, the square root of 5 is irrational and can't be written. It's going to be a repeating decimal, so I leave it like that. Step 3 is to simplify the expression if you can. Like if that is not, this is already in simplest form, but if it's not, then you simplify the root or the expression. So we'll talk about that in a second. I don't know if you can hear that vacuuming, but it's crazy loud at this place that I'm staying. All right. So I have x squared minus 36 is equal to 0. I want to solve by factoring, and then I want to use the square root method and compare. So for solving by factoring, I'm going to take the left-hand side. I know that's the difference of two squares. So what I actually have is x to the second power minus 6 to the second power is equal to 0. So that means that I can go directly to factored form from there. I know the first term in my factored form is x for both parentheses because that is the first thing that's being squared. So I have x and x. And then I know the second number I'm going to have is 6 in my parentheses for both. And I know that because I have 6 is the second term that's being squared. So that's going to be the second thing that I see in my parentheses. In one of the parentheses, I have plus, and in the other, I have subtraction. That way, that middle term is going to cancel out. And this is my answer. Sorry, that's my factored form. I apologize. And then I have to write the two equations from there. So I know this is A times B is equal to 0. So using my zero product property, I can say either x plus 6 is equal to 0 or x minus 6 is equal to 0. And then I solve those two equations. I get x is equal to negative 6 or x is equal to positive 6. And that's my answer. For factoring, then, if I do this solving by square root method, I have x squared minus 36 is equal to 0. I want to isolate the x squared, so I'm going to add 36 on both sides. And I got x squared is equal to 36. And then I'm going to take the square root of both sides, and that tells me my answer. I get x squared, taking the square root of that, I just get back to x, because squaring something and taking the square root are opposites. So I get x is equal to, or that's why I wanted to do that, so I would get x by itself on the left, is equal to, and then the square root of 36 is either positive 6 or negative 6. So I need that plus or minus 6, and this is my answer. So sometimes the square root method is easier. Sometimes you have to use the square root method because you can't factor. All right, let's do an example. So of the square root method, I have x squared minus 64 is equal to 0. So first thing I'm going to do is I'm going to get that x squared by itself. I'm going to add 64 on both sides. I get x squared is equal to 64. I'm going to take the square root of both sides to get that x by itself on the left-hand side. And that's equal to, now don't forget, positive or negative 8. Most of the time you should have two different answers. All right, example 2. This one's a little bit harder. First thing I want to do, I want to get that x squared by itself on one side. So I'm going to add 200 to get rid of the subtracting 200 on the left-hand side. And that gives me 2x squared is equal to 200. And now before I square the left-hand side, because that's going to give me an icky number to deal with, I want to get rid of this 2 that's the coefficient of x squared. And I can easily do that by dividing by 2. If I divide by 2 on the left, I have to divide by 2 on the right. And that gives me x squared is equal to 100. To get x by itself on the left-hand side, I'm going to take the square root. If I do that on the left, I have to do that on the right. And I get x is equal to the square root of 100. It could either be positive 10 or it could be negative 10. So I need to include the positive and the negative answer. Going down to example 3. I already have something being squared on the left-hand side. It doesn't look exactly the same as the other examples, but it is still something being raised to the second power, and it's already by itself. So I want to get back to that x. I want to solve for x, and the first thing I'm going to do that is I'm going to take the square root of the left-hand side. That's going to get me back to just x plus 1, what's inside of the parentheses. If I square that and then take the square root, I'm just left with what's inside the parentheses, x plus 1. If I take the square root of the left-hand side, I have to take the square root of the right-hand side. So, but I also have to remember when I take the square root, when I decide to take the square root, I need to include both the positive and the negative answer. So it's either positive 2 or it's negative 2. This plus or minus that I see on the right-hand side, this tells me that I have two separate equations that I'm talking about right now. I have one of the equations is x plus 1 is equal to positive 2. Or my other option is that x plus 1 is equal to negative 2. And then I solve those two for x. So I'm going to subtract 1 on both sides from both of these equations. And that's going to give me x is equal to 1 or x is equal to negative 3. And that's my answer for that problem. And then this last example here, first thing I'm going to do, I'm going to eventually isolate that x squared. So I'm going to add x on both sides. And I get 18x squared is equal to 8. The reason why I want to get the x squared by itself is because I need to use the square root method, which is to take the square root of both sides to solve for x. So I need to get something squared by itself on one side. I'm going to divide both sides by 18 now because I want to get that x squared by itself. If I take the square root of the left-hand side as is right now, I'm going to have a really icky number to deal with, and I'm not going to be able to solve this for x. So I first want to get rid of that 18 that's in front by dividing by 18. If I do that on the left, I have to do that on the right. I'm left with x squared is equal to 8 over 18, which simplifies, let me just simplify it, to be 4 over 9. So I can divide the top by 2 and the bottom by 2, and that gives me the 4 over 9 that I'm talking about there. From there, now I can take the square root of both sides. So I could take the square root of the left-hand side, so I'm left with x on the left-hand side. If I do that on the left, I have to do that on the right, so take the square root of the right-hand side. When I take the square root of a fraction, it's the same thing as taking the square root of the top and taking the square root of the bottom. So my answer here is, in the top, the square root of 4, it's either plus or minus 2, and in the bottom, it's 3. So I only have to include the plus or minus once for a fraction. I need to say that it's either going to be positive 2 over 3 or negative 2 over 3. So really my answer is over here, x is equal to plus or minus 2 over 3. Okay. And you could also write that as x is equal to 2 over 3 or x is equal to negative 2 over 3 if you prefer separating them. Next, we're going to talk about the completing the square method. So before we talk about the actual method, let's first look at for a pattern that we see when we multiply the same expression by itself. If I have x plus 1 squared, that's x plus 1 times x plus 1, so x plus 1 multiplied by itself, which gives me x squared plus 2x plus 1. If you FOIL that out, that's what you'll see. X plus 2 squared, that's x plus 2 times x plus 2, which gives me x squared plus 4x plus 4. And then if I have, for x plus 3 squared, we have, it's going to be x squared plus 6x plus 9. And then for x plus 4 squared, it's going to be x squared plus 8x plus 16. And you can check those if you want to with foiling them. But these are what we're going to get. I'm going to erase this so it's easier for us to find a pattern. We just get rid of the stuff we don't need. This is what I need to find my pattern. So I'm going to move this over here. And now I'm going to look for a pattern. So first of all, I want to look for the unique things that I see in the factored form and compare them to the unique things that I see in the simplified form. So in the factored form, the unique things that I see are what I'm adding inside of the parentheses. So plus 1, plus 2, plus 3, plus 4. That's what makes all those things different. I have what makes my simplified form different is this plus 2 in front, this plus 6 in front, this plus 4, plus 6, plus 8. That b, whatever the b is, that makes that quadratic expression unique. And then I want to look at what's the pattern. Sorry, before I do that. It also makes it unique that I have plus 1, plus 4, plus 9, plus 16. Whatever my c is, it makes my quadratic expression unique in simplified form. So I want to look at the red numbers. Look at how they compare to the yellow numbers in the factored form. Well, to go from 1 to 2, from 2 to 4, from 3 to 6, from 4 to 8, what is the pattern there? The pattern is I'm taking 1 multiplying by 2 to get 2. It's 2 times. The red number is 2 times the yellow number, so I'm taking 2 times 2 to get 4. I'm doing 3 times 2 to get 6. I'm doing 4 times 2 to get 8. That's the pattern that I see. And then I know that b in the simplified form is always going to be equal to the number in factored form multiplied by 2, or you could say double the number in factored form. You're going to take the number in factored form and multiply by 2 to see what your b is. Then for the blue numbers, how do I get from 1 to 1, from 2 to 4, from 3 to 9, from 4 to 16? How do I do that? What's the pattern there? To get to c, I'm going to take the number in factored form and square it. And that's going to give me c. This is 1 squared. This is 2 squared. This is 3 squared. This is 4 squared. So if I wanted to write a general formula here, I'm always going to have, this is the same. The first term is always going to be x squared. The second term I'm going to have is my x term. The coefficient to that is going to be whatever 2 times the number is. So if I have p, it's going to be 2p. And then for the blue, to find the blue number, I'm going to take p and I'm going to raise it to the second power. So I took this number inside of the parentheses and I raised it to the second power. And that's what I do to complete the square. So this form that we see here, this is called a perfect square trinomial. So if I see this form, it's called a perfect square trinomial. Okay. So trinomials, if you want to cracked English for that statement, since I'm talking about expressions, plural. All right. Now I'm going to complete the square of all of these things I have. So, and then I'm going to factor. So if I wanted to complete the square here, I wanted this whole thing to be a perfect square trinomial, I would have to find what number am I going to put here. This is what I'm going to be doing for the complete the square method. So in order to find what z is, I'm not talking about z, I'm talking about p. So in order to find what p is, I'm going to have to take this number in front of the x, and I'm going to have to divide it by 2, go backwards. I know 2p is the number in front of x. Well, I want just p. So I can take this number in front and divide by 2 to get back to it. And that gives me 3. And then I'm going to take 3 and I'm going to square it. And that's going to be what goes here. So 9 goes there. So I found what number would be in factored form. I took that number and I raised it to the second power to see what would complete the square. And if I wanted to rewrite this whole thing now, I would rewrite it as x plus something squared. And the thing that goes in there is the 3 that I found was p. Okay. All right, for example 2, to find what p is, I'm going to take the number in front of x, and I'm going to divide 2. That gives me -4. Then to find this number, I'm going to take -4 and square it. And -4 squared is 16. If I wanted to factor this, I would have x minus 4. So this -4 goes inside here in my factored form. All right, going to number 3. To find p, I would do -7 divided by 2, which is, I'm just going to leave as an improper fraction. To get this number, I'm going to take -7 over 2 and I'm going to square it. I know that that's 49 in the numerator and 4 in the denominator. And if I wanted to break this down into factored form, I would write x minus 7 over 2 because I found that p was -7 over 2. Then for example 4, I'm going to take the number in front of the x. To find p, I'm going to divide 2. That gives me 8. I'm going to take 8 and square it to get this number here, which gives me 64. I know if I break this down into factored form, I'm going to have x plus 8 because p is 8. That's what goes in my factored form. All right, so what is the completing the square method now that we went over that? Completing the square method, the first step is to isolate. So So I want to isolate the x terms. So all of the x terms, not just the x squared. I want to get that on one side and get constants on the other side. So get the constants, that's just regular numbers, in case you forget, on the other side. Okay. All right, so that's the first step. Let me think of an example. So if I have x squared plus 16x plus 2 is equal to 0. The first thing I want to do is I want to get that 16x by itself. So I want, the x squared and the 16x by themselves because I want my x terms all on one side and the constants on the other. So I'll end up with x squared plus 16x is equal to 2. All right, second step of what I'm going to do, I'm going to take the coefficients. So the coefficient of the x term. And I'm going to, which is p, and I'm going to divide by the square. Wait, I'm going to divide by 2. I'm going to divide by 2, just like I did in all those examples, and square. And that's going to be the number that I add. So after I do that, I'm going to add that number. Then add that to both sides. Okay, so I'm going to find what 16 over 2 is. 16 over 2 gives me, so p is equal to 16 over 2, which means p is 8. So I have x squared plus 16x plus 8 is equal to 2 plus 8. I added that on both sides. So I added plus 8 on the left and the right. All right, step 3 is to factor. So step 3 is to factor this expression that I got on the left. So to factor that expression, I'm going to have x plus p over 2, plus b over 2 squared. So if I wanted to factor the left-hand side here, I just did this. I know it's x plus 8 squared. It's x plus 8 squared is equal to, on the right-hand side, I have 10. So from there, I'm going to take the square root of both sides. I'm going to use the square root method from there. So take square root of both sides. All right, so if I look over here, I'm going to take the square root of the left-hand side and the right-hand side. That's going to give me x plus 8 on the left-hand side is equal to the square root of 10. I'm going to, on the side here, the square root of 10 breaks down into, oh, nope, you can't break down any further. It's the square root of 10, so I leave it because it's an irrational number. I just need to make sure I write plus or minus the square root of 10. And then I'm going to get the x by itself because I always want to solve for x by subtracting 8 on both sides. And that gives me x is equal to negative 8 plus or minus the square root of 10 is my answer. All right, so I'm going to take the square root of both sides and solve like I just did for x. Okay, always solving for x for equations that have x in them. You're always solving for that missing variable when you have an equation. All right, let's do an example. So another example because I already did one. I have x squared plus 12x plus 4 is equal to 0. First thing I want to do is get my constants on one side, my x terms on the other. So I want to isolate the x squared plus 12x on the left, and then on the right I have negative 4. From there, I want to see, what do I have to add? So what do I have to add to the left-hand side? And I'm also going to have to, do not forget to add it to the right-hand side as well, because you've got to keep the equation balanced. You can't just add whatever you want. It's chaos. So I need to find what goes here. So I put the number that's to find what number goes there, I'm going to take the number in front of the x. So I have 12. I'm going to divide 2. That gives me what p is equal to. And then that's 6. And then I'm going to take 6 and square it, and that's what's going to go here. So I'm going to take 6 and I'm going to square it, and that's what goes here. And that is 36. If I add 36 to the left-hand side, because I want to be able to factor that thing on the left, I'm going to add that same thing to the right-hand side. This gives me, when I factor the left-hand side now, I can rewrite this as x plus 6 to the second power. Now I have something squared on one side, and I have a constant on the other, so I have 32 on the right-hand side. Now I can use the square root method to solve this thing, since I have something squared by itself on one side. I'm going to square the left-hand side to get back to just x plus 6. If I take the square root of the left-hand side, I have to take the square root of the right-hand side. And that's going to give me plus or minus. I know once I decide to take the square root, I need to include the plus or minus. And then on the side, I'm just going to break down 32 because I need to simplify if I can. So the square root of 32 simplifies to the square root of 16 times the square root of 2. So I want to take out the biggest perfect square because I know that the square root of 16 I can rewrite as 4. So I have 4 times the square root of 2, which is 4 square roots of 2, and that's the simplest I can make it. Then I'm going to subtract 6 on both sides to get that x by itself, and it gives me x is equal to negative 6 plus or minus 4 times the square root of 2, and that's my answer. And then for the last example, first thing I want to do is get the x terms by themselves on one side, so I need to get that 8x to the other side by subtracting it from the right. And I get 4x squared minus 8x is equal to negative 1. From there, I want to see what completes the square. I don't. I have a 4 in front of the x squared. That doesn't work for me for a perfect square. I want that to be x. I just want it to be 1 in front. So what I'm going to do is I'm going to divide by 4 to get rid of that 4 that's in front. If I do that on the left, I have to do that on the right. I get x squared minus 2x is equal to negative 1/4. From there, on the left-hand side, what do I add to complete this square on the left? And make sure you also add it to the right. Well, I take negative 2 to find p. I take negative 2 and I divide 2. And that gives me negative 1. And then I take negative 1 and square it. And that's what I put here. And that is 1. If I add 1 to the left, I add 1 to the right. Now I can rewrite the left-hand side as x minus 1 squared, because negative 1 is p, so I put negative 1 there, and that gives me negative 1/4 plus 1 is 3/4. I take the square root of the left-hand side to get that x minus 1 by itself. Do that to the right as well, so x minus 1 is equal to plus or minus the square root of 3/4. I'm going to add 1 to both sides. And I finish with x is equal to 1 plus or minus the square root of 3/4. Done. Oh, wait, I'm sorry. I can actually simplify this. The square root of 3 is what I have in the top, but I can simplify the bottom because it's the square root of 4, which I know is 2. And that's my final answer.